Day 15. We've got some beacons. We've got some beacons today, and it's a late one for me, reasonably late, so I'm going to get on with it. So we've got this input, sensor at XYZ, closest beacon at XYZ. So that's fine. They all go onto this grid. I say this grid, we'll come back to that. And the rule is that a beacon has a sensor has a closest beacon, and so we can say that there are no other beacons in this zone, because if there were, then they would be in this zone, and this wouldn't be the closest beacon anymore. That's that, really. Simple idea. We're using Manhattan distance, which means we go, to get the distance, we go across, down, across, down, across, down, across, down, across, etc. So distance between these would be 1, 2, 3, 4, 5, 6, 7, 8, 9, or whatever it is. And our job is to essentially calculate the number of cells in a particular row that cannot have a beacon in them. So easy enough. Until we get to this point, in the row Y2 million, how many positions could not contain a beacon? If we look at the input, nice short input, but of course we've got, kind of big numbers here, right? Big numbers. So that is going to take us some work, because we're not going to visualize this, obviously, because they go, this one's even got a minus number in here, so that's problematic. So that is the challenge, and the naive solution is to just make a grid and just knock out all the points that can't have a beacon in them. But of course, because these numbers are so large, we're going to run into trouble with that. Probably we could do it, but it would be just horrible, really horrible, and probably wouldn't be very performant. In fact, I'm almost willing to guarantee that it would be an absolute nightmare. So we're not going to do it that way. We're going to do it a different way. This is my plan. So essentially, here's the example input. And I've plotted the numbers along, and we can use this to see the different grids, right? And what I figured I would try and do is, if we're looking at a single row, let's say it's row 9, what we really need is the first and the last index, and then we can count between them, just subtract the indexes. So if it's 15 and 1, of course, there's 14 cells that can't contain a beacon on this line, and we just have to plot for every sensor and beacon. We have to figure out a way of working out what the start and end intersection is on a particular row, and then find a way of merging them together in some way, and then we should be able to solve our problem. Essentially, we should end up with a list of ranges, and the ranges, all the numbers in those ranges, inclusive, are our that's our end number. So if we chose 9 here, we'd get 1 to start and 15 to finish, and so we get 14 would be our answer. 14 spaces that couldn't have the beacon in it, because it will be closer to a sensor than this beacon, and we just need to do this for all of them. So I figured we can use some mathematics to do this. And so I went and just plotted a few out and looked at R7 and R8 and figured out what they really were and tried to come up with a formula. And I just sort of muddled around with it for a bit, and then I tried it with this version, which has 3 on it. And the formula I came to is this. So what we've got here is where I don't actually think this is, I think this is just for all of them, really. For all of them, for all r's, and we'll call r is the row number, then the start point is the x coordinate of the sensor minus the distance between the beaker and its sensor, plus the absolute value of the row we're looking at minus the y coordinate. So what this essentially amounts to is taking the x value, which is let's look at row 2. For if we want to work out what the intersection is for this sort of diamond here, then we take the x value, which in this case of the s is going to be it's going to be 8. So we take 8 and we start off at 8, and then we subtract the distance between the sensor and the beacon, which brings us really to this point here, and then we add back the row less the y coordinate. So here, if the distance between the y coordinate is so 7, 6, 5, 4, 3, 2. So we've got 5 really. So we need to go 5 along. 5, 4, 3, 2, 1, 0. And we get to this point. So really, we're taking the number of steps up it's gone and subtracting them from this number. So we end up getting to here. So this is a bit noisy, I know. And yeah, that's essentially it. And then we do that we do that for every sensor and beacon pair, which we don't have that many, remember. So we can do that quite easily. And then if it's a negative output, let's say the start is greater than the end, like this one here, so S3 down here, we can say it's not relevant because it's gone in a cross. So it's gone all the way up and it's starting to expand into infinity. We don't care about those. The end has to be greater than the start or equal to. And then once we've got some pairs, once we've got some ranges, we need to merge any ranges. So you can see here, of course, if we counted this diamond's and this diamond's cells, we get duplicates. So we'd need to take, for example, if we were looking at line 7, we need to take this range and sort of merge them in somehow, which is, we can actually do with the logic, I think, from an earlier challenge. And in any case, if it turns out to be slightly wrong. So I basically just copied this from challenge. Which one was it? I think it was day 6 or day 7 or day 4. Yeah. So it's day 4, part 2. Day 4, part 2, we had some segments. So let me show you this. So we had some segments here, and we got to get the small and the big segment. And first we need to find out whether they overlapped, or whether one was totally contained within the other, and then we got an is overlapping. So we got an algorithm for that already. I think it still works. I mean, I've tried it out with a couple of examples. It might not. I might just be jumping to the conclusion on it. In any case, I think it's probably close enough. So what we need to do now is to pass the input, which I might not actually do considering it's quite short. I could probably just Command D my way through this. Generate some ranges for each row. Yeah, for the row that we're looking at. Merge any overlaps, and then calculate the total spans by subtracting getting the difference between the start and the finish. And then we've got our number. So in principle, should be quite straightforward. I don't know why I keep saying that. Clearly, I am a glutton for punishment in forcing myself to look like a fool in front of the 0 people who are watching this. Anyway, enough of my psychodrama. Should we get on with it? I think we should. I am going to just take a little bit of time to plan out the state. So the state, we're going to have the sensor beacons. We're going to have the row that we're looking at. We're going to have the ranges. We're going to have we're going to have the ranges, and we're going to have merged ranges. I think, or we could potentially have a class. So we could have a sensor beacon class, and we could have it to have a sensor X, sensor Y, beacon X, beacon Y, and then we could have something to calculate the distance and something to calculate the range for the row. And then that would then do most of our work, right? I think that's true. So then we can just store these. We can store the row. We can store we don't need to store the raw ranges. We can just merge them. So that's basically it. And then a kind of viz. Probably nice to have a viz if we have time. So in terms of other functions, I want to have a calculate. That's sort of, I'm not going to pass the input using code. I'm just going to get it in there. I don't need to generate ranges. I do need to have a merge overlaps, which I'm going to do pairwise, I think. Yeah, we just need to go through. There's not going to be that many. It'll be like 20 times whatever. I just need to go through them all. Or I could possibly sort them by their start point. I could probably sort them by their start point, or I could try that out anyway. So merge overlaps, and I need to have a calculate total. Calculate no beaconless cells. And I need to have a merge overlaps as well to create this. So my plan of action is 1, write state, 2, actually write sensor beacon, 2, lunge input of trial, 3, write state. I'll have some sort of viz. 4, okay, I've been signed out of Google, signed out of Zoom. In one moment. Okay, back now. Yeah, so write state and viz, then write calc beaconless cells and merge overlaps. Okay. So I'm going to take these. Yeah, okay. Let me put my trial, put my little trial. Put in my little one. I'm going to put in a real trial. Oh gosh. And then the real one as well. Okay, and I'm going to create a new terminal. A new terminal as well. Get the TTY. Get this working. Oh gosh, okay, that's not what I wanted. Okay, we're set up. Great, let's go to part one. And now I'm going to reset my timer and get going. Okay. Okay. To have this and this, and then I'm going to check that. Eight, 7, 2, 10. Distance should equal 9. Okay, so to do this, we've got to do self sensor x, sensor x minus self sensor, no, beacon x and then y. I don't know why I choose a new coordinate storage system every single time. Oh, sorry. Okay. Wrong directory. Okay, let's import that. If I can get my editor to do this for me or not. Okay, great. Okay, that works. And let's do it with a couple others. Okay, 16 and 7, 19 and 4 should be 6. Great. And then 17, 20 and 21, 22 should be 6 as well, actually. Okay, that's good. Great. Okay, now range for row. We're going to use this. We're going to use my formula for this. So return self sensor x minus self distance plus the absolute value of, I'm sure this is, so we could make this simpler in some way, but I'm not going to. Self sensor y. Okay, and then if we run a few checks on this, and I'm going to have yeah, so this one's going to be, it's just going to be the 15, no, the 4, 15, and 29. It's going to be for row 2. Okay, that all works. And then we're going to say this is going to be the start. The end is going to be slightly different. So this is going to be plus and minus. I'm going to return the start and the end. This is going to get us 4 and 12 as we expect. It's going to get us 15 and 17, and it's going to get us 29 and 5. Now, I happen to know that if we make a range out of this, we're going to end up with something wrong. So we're not going to convert this to a range anyway, so it doesn't matter. Great. Okay. Brilliant. So I've made my sensor beacon. Now I'm going to munge the input of the trial file. I'm going to start with the little. And I'm going to say trial data. I'm going to say input data. And you know what I've learned? If you're going to do this, never type the numbers yourself. Never type the numbers yourself. The numbers should remain pristine. You cannot change them. You cannot touch them. You cannot type. You cannot touch the number keys at all. They have to remain perfect as they were. And you cannot touch them. Am I where I want to be? Yes. Okay, perfect. Just one more step and then I'll be good. Oh, sorry if you spent ages parsing that. Okay, let me move this. No, that's actually fine. Okay, so we've got our munged our input, and now we're going to look at the state, which I'm going to put here. What needs to be in state? Okay. Okay. Default. Okay. The row is going to be an int, which will initially be, actually, I don't think I need to have these be defaults. I'm always going to need to specify them. Merged ranges is going to be a list of tuple of int, no. And that is going to be a field. Just going to be a list. And then we're going to have a viz, which I'm just going to have it be that for now. I don't think I might not even need it. Okay, great. Now, okay, fine. So now for this, our first thing is going to be the ranges. Let's have this for 2, because I know what that's going to be. Okay. And we're going to get the ranges. Okay. All right, 4, 12, 15, 17, 29, 5. Great. Okay. And then we're going to need to merge the ranges. I don't even think I need that anyway. I don't think I need that. Okay, and then we're going to have this first. Just make it equal to the ranges because these are not overlapped, so I can just move ahead with that. So okay, so don't need that, don't need that, don't need this, and then I want to calculate cells. This, I'm going to go through each range. What's it called? That be there. It can be 0 initially. Okay, state output equals sum of the state merged ranges, and it's going to be okay. So that's 34. Which is or 2. Yeah, okay. I'm including the wrong ranges. So I need to discard some ranges. Okay. If 0 is less than or equal to this. Okay, so that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's wrong. And I'm also signed out of Zoom. I'm going to try and ignore that. Okay, so that's wrong. What are my ranges? Okay, so we've got 4 and 12 here, and then we've got 15 and 17. Now that's right, it's just it's getting the wrong output. So 12 minus 4 is 8. And actually we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it needs to be minus 1, 8. So it's now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we should have 12 actually. So that's not something's wrong here. Okay, so the last one should definitely be 3. So 15, 16, and 17. So we've got 15 minus 17 is 2. So this should be plus 1. That's the right one. Okay, so I had a wrong ending. Okay, fine. Great. I'm just going to take a moment to sign into Zoom because I seem to be signed out again. Just in case that upsets the recording. Okay, that's fine. Right. Okay, so that gets us as far as that. Let's look at 3, which should contain a few more. 16. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, that's good. This one should start to be wrong. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, so that's too many now. So I need to properly do some merging. So if we sort the ranges, what do we get? Well, that's right. Now, what if they just turn up in the wrong order? Okay, and if I don't sort them, is it really sorting? Okay, yes, it is really sorting. Great. Nice. And if this one, XY, this one ends up here. Okay, so it still ends up in the right place. Okay, that's good. Now, for R in state ranges. Now let me steal from this. Nope, wrong one. Wrong one. Wrong one again. Okay, let me steal this. Okay, so they're correct. Great. If is overlapping. I kind of want pairs, right? If is overlapping. Great. Okay. I see why this is taking a while. If is overlapping, state ranges index -1 and R, then we merge them by saying the merged ranges should equal the no, wait. I need to think of this. Okay, current range is the first range. Okay, and then we're going to iterate over every range after this, and then if the current range is overlapping with our new range, then the current range should be made equal, should be merged into it. So let's say it should then be the current range first and the range second, so end. Otherwise, the state merged range should have appended to it the current range. And that should give us the right outcome, but it doesn't. Okay, so that's the first one. So 214, and the current range is okay. Okay, and then this one, right? Okay, and this one, great. Okay, so right, and so at the end we should also append the last one. So it's 18. Okay, so let's try 2 again, which shouldn't be 18. Okay, so this is right. 12. Let me actually start writing these down. 12, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, great. Next one down is 3, which is 16. And that is probably right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and yeah, 16. Then the next one is where it gets hairy. And we get, okay, that's no good. It should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it should be 18. But it's not doing it. We're getting here. Okay, that's good. All right, back to the top. 2 to 12, 3 to 16, 4 to 18. Great. All right, let's try the trial data and row 10. Should be 26, and it is. Okay, perfect. Now, let's try with the real data. And it's going to be row. I'm not going to mess this up by copy pasting it wrong. Okay, so it should be this. Let's try it out. uh, 4197102. Okay, let's switch back to the editor. So what's wrong here? Let's go back to the trial data. So it looks like all the ranges get rationalized down into one range, which is a little weird. Probably not what we want. Let's try it with the little data. Do we get everything we need there? So on line, let's try this out. So on line -2, we get 8 and 8, which is an output of 1. That's correct. -1, we get 3. At 0, we get 5. That's right. At 1, we get 8, which is... Okay, let me just copy this diagram in here as well. Okay. At 1, we get 7 plus 1. We actually get rid of all these, and then we can not have to deal with them anymore. Ugh. Okay, so this will tell us what we're expecting. So at 1, we get 8. That's great. At 2, we get 12, which is right. At 3, we get 16, which is right. At 4, we get 20, I get 18, which is right. Okay, 5 is 20, which is right. 6, we get 22, which is right. Okay, 7, we get 24, which is right. 8, we get 22. 9 should be 20. 10 should be 18. No, sorry, 10 to be 18. 11 should be 16. 12 should be 12. 13 should be 8. 14 should be 6. 15 should be 6. 16 should be 6. 17 should be 7. 18 should be 9. 19 should be 11. 20 should be 13. 21 should be 9. 11. 20, oh, sorry, 22 is 9. 21 is 11. Okay. All right, weird. On the trial data, y is 10, we get 26, which is right, where a beacon can't be present. And then we, with the input data, we get this, we get, oh, God, I'm signed up from Zoom again. We get this. Now, am I being silly here? Is this minus? Wait, what's the difference between these two? What's my room for calculating the output? The absolute of the difference between R0 minus R1. Yes, that's not right, is it? Yes, yes, yes. So it's these two numbers added together. 497. Oh, no. Wait. 101. Could it be just one difference? No, our number was too low. Oh, I'm so going to lose the gold today. 102. It's too, I'm going to submit it again. It's too low. It's too low. It's definitely the full input data, right? 66. 21. Um, hmm. Okay. Um, let's try out a few things. Let's try out this and then let's push them all across to the left by, let's say, minus 100. Let's minus 100 from all of them. It shouldn't change anything. And then let's see if it can handle minus numbers well. Because if it can't, then that might be a problem. Sorry. What? What are you talking about? Oh, yeah, okay. 2 minus 100 as well. That's still right. What could be wrong here? It's too low. We're underestimating it. It's too low. The most likely explanation is something silly, isn't it? Let me recheck this data. X and Y, sensor, beacon. Manhattan distance looks right. This looks right. There's a situation that is missing. Let's try with the trial data again. Because we do have results for 9 as well. We've got 10, which definitely is 26. We've got 9. How many is that? 25 selected. Oh no, way. That's 20. Oh God, they've screwed me over again. Okay. Eric, it is, if that is your real name, Eric, you're really bugging me now. So basically, here's what I think it is. How many positions can not contain a beacon? We need to exclude the positions that do contain a beacon, that we know contain a beacon, because we've put one, because there's one in there. So, oh, that really upsets me. We know there's a beacon in these 2 positions. In this one position. So it's less 1. It's less 1. Okay, and I've got the luxury of time now that I've lost my challenge to myself. Okay. But it said it was too low. It said it was too low. Let's try another one in the trial data. This one, let's try 11. Oh gosh, okay. So this one will take this out. This is 28. That's right. I think that's right. So this number, less the one beacon that is in Y 2 million, in principle should just be this less 1. No, still too low. Still too low. Let's try and code this out. Look at 9. So 9 should come out as 25. 10 should come out as 26. But it reads 10 should come out as 26. But we get 27? Yeah, 26, 27. We get 26. So we're getting the right. No, that's not it, is it? The beacon doesn't matter. The beacon's a red herring. Okay. Okay, so one thing we do know is they're all combining themselves for some reason. They've all got the same x for some reason. So we're checking whether these two overlap. And if this is the start range and this is the so the first one's range. So these definitely should combine. Let me look at these. Let me look at these. So in theory, this one is useless. This one is just obliterated by this one. Wait a minute. Some of these ranges are they all in the right order? Yeah, they're all lowest first, I think. Yeah. They're definitely ranges. And the highest is this one, right? Wait, this one's higher. That one's higher. This logic is wrong. That's the wrong answer as well. No, I've got to wait 5 minutes. Let's go through we know they all overlap, so I don't need to know that. Okay, so let's look at this. Let's check. Do these actually overlap? Okay, so by our logic, do these overlap? From minus 208,427 to this giant number, yes. So we get this range. And then the next range we should look at is, well, exactly that. Do these overlap? Yes. So we take the maximum and the minimum. Do these overlap? Yes, they do. So we end up taking these. Do these overlap? Yes, entirely contained by. Do these overlap? Yes, they do. So this logic looks fine. Okay, let's try it back with the little data. That's all correct. It's 27 now. Which is wrong. That's a step closer. Yeah, so if we subtract the beacons now, Well, now it's even more wrong. Oh gosh. Okay. Wait. 10. X, Y. Huh? What have I gotten wrong here? I've just realized I've got something hugely wrong. Okay, let me show you what I'm seeing here. So the closest beacon, so I'm looking for the beacons with Y10, because that's our row, right? So consider the sensor at 218. The closest beacon to it is at -2 X. Okay. For the sensor at 916, what? What have I screwed up here? -2, 15. -2 along the top, 15 in the rows. 2, 15. 2, 18. Okay, 2, 18. That's that, right? Yeah. Two, 2, 18. So 8, which is 8, 7. Sensor. The closest one is at 2, 10. 2, 10, 2, 10, 2, 10. They're on the same cell. They're on the same cell. That's why. That's why. So we can't do it that simply. We have to check. We have to be sure. We have to deduplicate that. Okay, fine. I can deal with that. Okay. You don't need to see my Googling. Python unique Oh, great. We've just got sets, don't we? Okay, brilliant. Fine, fine, fine. We'll just do life this way, shall we? Beacon X, SB, beacon Y. Okay, now we get 26. Can we rescue this at all from a lead? 2, 1, 2, 3, 1, 2, 3. Well, it's a different number at least. Let's try it out. Okay, that was a palaver. Fine, fine, it's fine. It's my mistake. I made a mistake. I didn't think of the beacons being in the row. It's fine. Okay, your handheld device indicates the distress signal is coming from a beacon nearby. The distress beacon is not detected by any sensor, but the distress beacon must have X and Y coordinates no lower than 0 and no larger than 4 million. To isolate the distress beacon signal, you need to determine its tuning frequency, which can be found by multiplying its X coordinate by 4 million and then adding its Y coordinate. In the example above, the search space is smaller. Instead, the X and Y coordinates can be at most 20. With this reduced search area, there is only a single position that could have a beacon, X14 and Y11. The tuning frequency for this is this. Find the only possible position for the distress beacon. What is its tuning frequency? Okay, fine. So we could iterate over it for 4 million times. It's no problem for us. We've got an efficient mechanism here. So we want to iterate over the y's, all y's, 4 million, and look for a cell, look for a range well, if there's only one, it's got to be the only one where there's two ranges, right? Or a range with a that spans less than 4 million, right? So the output's got to be less than 4 million. So we're looking for that, right? Probably. Okay, I'm going to get going with this. I think I can improvise my way to the solution here. So let's reset the timer. Let's go with part 2. Okay, so for n in range 1 to 4 million, is less than, or yeah, less than 4 million, then print row exit 1. Oh yeah. If state output then I should print the in. And let's get rid of this. $15 seconds, right? That's how long we're allowed to take, technically. This completes, I'm going to be annoyed. But it's probably around the middle. Or later. No way, actually, I'm thinking about this all wrong. Span could be less, so that's probably not actually gonna work. Okay, let me see if I can just print out each one, see if that gets us anywhere. Okay, so we're looking for a situation where, so if merged ranges, if the length of the merged ranges is more than one, we should definitely be interested in that. If the length, if the first is greater than 0, then we should definitely be interested in that. And if the end is under this number, then we should definitely be interested in that. I don't need all these. Let's see if that gets us anything interesting. Might get us too much. Okay, that's one interesting one. Yeah, that gets it. That gets it. So that would be, what number was that? What Y number was that? I didn't print it out, did I? Bloody heck. Okay. Now, try printing out the right output, Kate, please. Okay, so this is the Y value. So X, Y, X, Y. And I say X because this will actually be 7, 9. It's the number between these two. 7, 8, 7, 9, 80. So this is the right. That's right. And then the Y is here. And so we want to get the X coordinate multiplied by this number plus the Y coordinate, which would be this ridiculous number. Okay. I'm hoping for a second star here. All right. Well, that was a puzzle. You can't fault Eric for being a good puzzler. I definitely was tricked by that one. To be fair, I think the programming went without a hitch on that. It was perfect. I couldn't imagine a better programming step. The planning was good. The programming was good. It was all good. The issue was in my not paying close enough attention to the precision in some of the instructions. So I should do that more. It should look for the edge cases. All right. See you tomorrow.